Hi children, this is Kumar, mathematics teacher, grade 8. The next concept is representation of rational numbers on number line. Natural numbers. The line extends indefinitely only to the right side of 1. The line extends indefinitely only to the right side of 1. The next one is whole numbers. So the line extends indefinitely to the right but from 0. The line extends indefinitely to the right but from 0. So there are no numbers to the left of 0. There are no numbers to the left of 0. The next one is integers. The line extends indefinitely on both sides. The line extends indefinitely on both sides. Did you see any numbers between -1 and 0, 0 and 1? No, because it is an integers. There is no numbers between -1 and 0, 0 and 1. Now, let us see the rational numbers. The line extends indefinitely on both sides. The line extends indefinitely on both sides. In rational numbers, between 0 and 1, in rational numbers 0 and 1, so many numbers are there. In rational numbers, in between 0 and 1, so many numbers are there. Here, 0 and 1 between 1 by 2. Here, 0 and -1 between -1 by 2. But in rational numbers, in between two rational numbers, there are so many numbers are there. Next, how to represent rational numbers on the number line. So for example, how we can represent 5 by 8 on the number line. So 5 divided by 8 is a rational number. So there are two categories. First category is numerator is less than denominator. The second category is numerator is greater than denominator. Now is a 5 divided by 8. So 5 divided by 8 is numerator is less than denominator. So 5. So these rational number lie between 0 and 1. This rational number lie between 0 and 1 because it is numerator is less than denominator. Now 5 divided by 8. So 5 divided by 8 is denominator 8. Denominator tells us number of equal parts. Number of equal parts. Now let me draw a number line. 0. So 5 divided by 8, 8 equal parts. So 5 divided by 8 lie between 0 and 1. 0 and 1. So 0, 5 divided by 8 a positive rational number. It will be right side of 0. So 0, 1 divided by 8, 2 divided by 8, 3 divided by 8, 4 divided by 8, 5 divided by 8, 6 divided by 8, 7 divided by 8, 8 divided by 8. So 8 divided by 8 is equal to 1. Now is the rational number is 5 divided by 8. So 5 divided by 8 is here. Then the next another one example, 4 divided by 3. 4 divided by 3. So this is another category. So 4 divided by 3 is numerator is greater than denominator. Numerator is greater than denominator. 4 is greater than 3. 4 is greater than 3. So now, 4 by 3 is a improper fraction. 4 by 3 is a improper fraction. First we convert improper fraction to mixed fraction. So now 4 by 3. So 4 by 3 fraction to mixed fraction is 1 divided by 3. So 1 is a whole part. Then 1 by 3 is a proper fraction. 1 by 3 is a proper fraction. 1 by 3 is a proper fraction. So now what is the denominator? So denominator 3 tells us equal number of parts. Number of equal parts. Now 1 divided by 3. 1 divided by 3. So this rational number 4 by 3. We know that the rational number 4 by 3 is a lie between 4 by 3. So 4 divided by 3 lie between 1 and 2. 1 and 2 because here 1 is a whole part. So 4 by 3 is a lie between 1 and 2. So now let me draw a number line. So the rational number 4 by 3 is a positive rational number. It will be right side of 0. So here 0, 1. So 1 is nothing but 3 divided by 3. 1 is nothing but 3 by 3. The next 4 divided by 3, 5 divided by 3, 6 divided by 3. So 6 divided by 3 is 2. So now 4 by 3 is a rational number. So 4 by 3 is here. Rational numbers between two rational numbers. Rational numbers between two rational numbers. Between any two given rational numbers, there are countless rational numbers. Between any two given rational numbers, there are countless rational numbers. For example, find any three rational numbers between minus 5 by 6 and 5 by 8. Find any three rational numbers between minus 5 by 6 and 5 by 8. First, we convert minus 5 by 6 and 5 by 8 to the rational number with the same denominator. Now here denominator is different. So take LCM. So what is the LCM of 6 and 8? So LCM of 6 and 8. 6 and 8. So it's divided by 2. So 3 2s are 6, 4 2s are 8. The next third table. 1 3 is 3, 4. The next second table, 1 is 2. Next 2, 1, 1. So what is the LCM? So LCM of 6 and 8 is 2 into 3 into 2 into 2. So now we multiply. 2 3s are 6. 6 2s are 12. 12 2s are 24. So this 24. Now here what is the first rational number? First rational number is minus 5 by 6. So convert the denominator is 24. Now here the denominator is 6. So multiply and divided by the 4. 6 4s are 24. The numerator also multiply by 4. 5 4s are 20. Minus 5 into 4 minus 20. The next rational number is 5 divided by 8. Now the convert the rational number denominator is 24. Here 8. You multiply by 8. 8 3s are 24. Numerator also you multiply by 3. So 5 3s are 15. Here minus 20 divided by 24 and 15 divided by 24. But what is the question? Find any three rational number. Here minus 20 divided by 24 and 15 divided by 24. Here I write any three rational number. So in any three rational numbers between minus 20 divided by 24 and 15 divided by 24 is minus 19 divided by 24. Any three rational number you can write. Minus 19 divided by 24, 1 divided by 24, 3 divided by 24. That's all. Next example, write any two rational number. Write any two rational numbers between minus 1 and 0. Okay, minus 1 and 0. So minus 1 is a rational number, 0 also rational number. So now minus 1 can be written as, so minus 1. So minus 1 you multiply by and divided by 10. So what is the denominator is also 1. So minus 1 into 10 is minus 10 divided by 10. Then 0. 0 can be written as, so now here also you multiply and divided by 10. So 0 into 10, 0 divided by 10. Now, so minus 10 divided by 10 and 0 divided by 10. So what is the question? In rational number minus 10 divided by 10 and 0 divided by 10. So the question is minus 1 and 0, write any two rational number. Here so many numbers are there. So write any two rational numbers. So the two rational numbers between minus 1 and 0 is minus 9 divided by 10 and minus 8 divided by 10. Here write any two rational numbers between minus 1 and 0. Next exercise 1.2. In exercise 1.2 I will explain a few sums. Remaining sums do it yourself. The fifth question is find 5 rational numbers between 2 by 3 and 4 by 5. Find 5 rational numbers between 2 by 3 and 4 by 5. First we convert 2 by 3 and 4 by 5 to the rational number with the same denominator. So what is the denominator is 3 and 5. So first we take a LCM of 3 and 5. So what is the LCM? So 3 and 5. So no common factor. So here 3, 1 is 3, 5, 5, 1, 1. Now multiply 3 into 5. So 3 5s are 15. So the LCM is 15. So first rational number is 2 by 3. So 2 by 3 convert to the 3 in 15. So here 3. So multiply and divided by 5. So 3 5s are 15. 2 5s are 10. So 2 by 3 is equal to 10 divided by 15. The next one is 4 divided by 5. The next fraction is 4 divided by 5. Convert to the rational numbers in denominator is 15. So now 5. You multiply and divide by 3. 5 3s are 15. 4 3s are 12. Now you see rational number 10 divided by 15 and 12 divided by 15. Here 10 divided by 15 and 12 divided by 15. Again you multiply and divide by any number. For example, multiply and divide by 10. So 10 tens are 100. 100 divided by 150. The next another one rational number 12 divided by 15. So multiply this and divide by the same number 10 divided by 10. 12 tens are 120 divided by 150. Here 100 divided by 150 and 120 divided by 150. Here in between so many numbers are there. Write any 5 rational number. Any 5 rational numbers are 101 divided by 150, 102 divided by 150, 103 divided by 150, 104 divided by 150, 110 divided by 150. So any 5 rational numbers between 100 divided by 150 and 120 divided by 150. Second one is represent minus 2 divided by 11, minus 5 divided by 11, minus 9 divided by 11 on the number line. Minus 2 divided by 11, minus 5 divided by 11, minus 9 divided by 11. All the denominators are same. What is this denominator? 11. Here also 11. Here also 11. In number line, between 0 and 1, divide 11 equal parts. All the denominators are same. Divide 11 equal parts. So represent these 3 rational numbers on number line. So divide 0. Here all are negative. In 0 and minus 1, divide 11 equal parts. So here 0 divided by 11 is 0. The next one is minus 1 divided by 11, minus 2 divided by 11, minus 3 divided by 11, minus 4 divided by 11, minus 5 divided by 11, minus 6 divided by 11, minus 7 divided by 11, minus 8 divided by 11, minus 9 divided by 11, minus 10 divided by 11, minus 11 divided by 11 is minus 1. Now represent minus 2 divided by 11, minus 5 by 11, minus 9 by 11 on the number line. So what is the first rational number? Minus 2 divided by 11. So where is the minus 2 divided by 11? So here minus 2 divided by 11. The next rational number is minus 5 divided by 11. So here minus 5 divided by 11. The next rational number is minus 9 divided by 11. So where is the minus 9 divided by 11? So here minus 9 divided by 11. That's all. This chapter is over. Now I will give you the small review of this chapter. First, the rational numbers are closed under the operation addition, subtraction and multiplication. The operations addition and multiplication commutative for rational numbers, associative for rational numbers. The rational number 0 is the additive identity for rational numbers. The rational number 1 is the multiplicative identity for rational numbers. Additive inverse of the rational number a by b is minus a by b and vice versa. The reciprocal or multiplicative inverse of a by b is b divided by a. If a divided by b into b divided by a is equal to 1, then the distributivity of rational numbers for all rational numbers a, b and c, a into b plus c is equal to a into b plus a into c. A into B minus C is equal to A into B minus A into C. Then rational numbers can be represented on a number line. Between any two given rational numbers, there are countless rational numbers. That's all. Thank you. I give 5 questions. Do it yourself.